Okay, we are reviewing dilations. What was dilations again, Miss Green?
To make bigger or to make smaller?
To make bigger or smaller. So it's a change in size.
Right.
Does the shape change?
No.
No, just the size.
Yep.
Okay. Your learning target today, it's a little, let's, zoom out, which is a dilation in itself. We will dilate objects at a coordinate grid by multiplying by a scale factor. Are we dividing at all?
No.
No, we just multiply by a scale factor.
Means to multiply.
Which, look here, scale factor. The amount you multiply by when you get the wow, I don't know what I wrote. The amount you multiply by to get the dilation.
There you go. You got it.
Then a scale factor of 3, you're going to multiply by 3. A scale factor of 1/2, you multiply by 1/2. So if I have the point 1, 2 is dilated by a scale factor of 2, what's the new point?
Well, you're going to multiply by 2.
You're going to multiply by 2, so you end up with 2,
4.
4. Pretty simple, right?
Yep.
So dilate by this shape by a scale factor of 1/2. Or 1.5, I'm sorry, 1.5. So I have to look at this and I have to find my points and I have to dilate them. So A was at 1, 1. B is at 2, 1, 2, 3, 4, 5. So 2, 5. And C is at 2, 2. No, I'm sorry. 5, 2.
Or no. 1, 2, 3, 4,
4, 2. We're not good at this. So
says your math teacher.
Hey, I'm sick. Can I call that as my excuse? So now we just have to multiply each of these by 1/2. Or I'm sorry, 1.5. 1.5 is right here. I know they can't see it in the video right now, but 1.5. So what would our new point for A be?
For AB or for A?
For A.
1.5, 1.5.
1.5, 1.5. What's our new point for point B?
Point B, 1.5 of 2 is 3, and 7.5.
Oh, that's a 5. And what's our new point for C?
6 and 3.
Okay, now all we gotta do is put it on. So 1.5 would be here.
I'm gonna zoom in a little bit.
Yeah. 3, 7.5, 1, 2, 3, 4, 5, 6, 7.5. And yes, it's okay to have 0.5. And then 6, 1, 2, 3, 4, 5, 6. 1, 2, 3. It's gonna go right here. Does that look bigger?
Yeah, same thing, just a little bit bigger.
Isn't that fun?
So much fun.
Okay. Dilate this trapezoid by a scale factor of 1/2. So if I'm doing 1/2, is it going to get bigger or smaller?
If it's half, that's smaller than 1, therefore it's going to become half the size. It's going to get
So it's going to be smaller.
Yeah.
So this original point is 2, 2. If I dilate that by 1/2, it becomes
2, 2, 1, 1.
1, 1. And then if I've got 1, 2, negative 2, 2.
You're going to just do the exact same thing on this side.
Right there. This one here, we've got 1, 2, 3, 4, 5. 1, 2, 3.
Will you write them down so they can see it? You can write it right here.
So I've got 5, 3. What does that become if I dilate it by a half?
Oh, by a half, 2.5 and 1.5.
Those halves again, tricky. So 2.5, 1.5. And then this one was the same thing, except for this one, this one was negative and negative, and this one is 5, negative 3, which turns into 2.5, negative 1.5, which goes 2.5, negative 1.5, right there.
It becomes a baby.
It becomes a little baby one. Is it about half the size?
Yep.
It better be, because we dilate it by a half. Do one more. Dilate by a scale factor of 1/3. Is it going to get bigger or smaller?
1/3. Smaller, because it's going to become 1/3 of the size.
Yep. So if we've got 1, 2, 3, 4, 5, 2. I'm sorry, I did not make this one happy. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And that would be negative 6. 1, 2, 3, 4, 5. Negative 5. So what is 5 times a third?
1.6.
So 1.6, and then what is 2 times a third?
I'm doing it right now. 0.66.
So 0.6. Repeating. So we'd be about 1, a little over here, about right here. Oh, that's not too bad. Yeah. Now, negative 6, 5. So negative 6 times a third would actually just be negative 2.
Right.
And then 5 we discovered was 1.6. So we're now at negative 2 and 1.6 right there. And then this one, we've already done the negative 6, so that's negative 2. And we've already done the 5, so it's negative 1.6. I mean, a lot of these numbers are going to repeat each other. So negative 2, negative 1.6, yeah, about right there. And there's our new little triangle. Look at the cute little baby triangle.
Third of the size.
And that's it. I mean, dilations is pretty easy. All you're doing is multiplying by your scale factor.
So, I just wanted to say something about this one. The reason why I didn't stay, like, right on top of it is because it was not over the origin. If it's over the origin like this, it'll stay within the origin.
Yep, and that's okay if it shifts. That's part of dilation. You're going to see some shift, some don't. Anyways, we are out. Bye, guys.
Bye.